Hi, team. So you did your do now, and now we want to go over homework. So I just remind you to do some self-care this weekend, whatever that looks like for you, and do something a little bit extra special. Don't do just like, take a shower or whatever. I mean, take a shower, that's great. Please do that. But like, do something a little extra special, like do a deep conditioning or a mask, or go for a walk, or cuddle your dog, or hang out with a little sibling. Like, do something a little extra special that makes you feel good. All right, so today we're going to talk about different types of research, and then you're going to do some work actually identifying those types of research. And I'm going to say to you what I've been saying before, and what you'll hear me say many times, is that you can use your notes when you're doing work like this, but really, I wouldn't. Because if you don't start trying to apply the knowledge without always having your notes there, you're going to find that all of our unit tests and our chapter tests and stuff are really hard. You need to not to be able to do this stuff without your notes. Okay. So you can go ahead and get your date set up. You can see I changed it. And we're still in our scientific foundations unit, and today we're talking about types of research. So let's start with experiment. We talk about experiments all the time, and in the world in which we live, they kind of have come to mean like kind of whatever, any type of thing where we're figuring something out. But an experiment is actually very strict, and has a very, very clear method. So, excuse me. Ooh, so yawny. An experiment is when we're in a lab. So an experiment can't really happen in the real world. We're in a lab and we're trying to figure out one thing, what one thing does, right? So this is where we get our terms independent variable, dependent variable. So an independent variable is the one thing that we change that we're trying to figure it out. So let's do an example with this. Let's say that we're doing an experiment on how how more than 3 cups of coffee a day affects your sleep. Okay. In that experiment, our independent variable would be the coffee, because we can change that. We can tell people not to drink coffee, or to drink coffee, or when to drink it, or whatever. We can manipulate that variable. Therefore, it is independent, right? It's on its own. It doesn't need anything else in order to change. Then we have our dependent variable. And in the case of psychology, that's the behavior or the mental process that's affected when we manipulate the independent variable. So in our experiment about coffee and sleep, sleep would be the dependent variable. The quality of sleep, your length of sleep, that is dependent on coffee, which is our independent variable. Okay. These can be a little bit tricky for some of us. We're going to talk about them so much throughout the year that you're going to know it cold. All right. And then in experiment, we always have 2 groups. So we have an experimental group. They're the ones getting the treatment. So, excuse me, I don't know what's going on. They're the ones getting the treatment. So in our case, in our experiment, they would be the people drinking coffee. And then we have a control group. This is the group that doesn't get treatment. Their independent variable is not changed. So in our experiment, this would be the group that does not get coffee. Okay. So that's a quick and dirty on an experiment. Let's talk about correlational studies. So correlation is relationship. It's just a fancy way to say relationship. So a correlational study looks at that relationship between how 2 variables change together. So does one change much faster than the other? Do they both go up? Do they both go down? Does one go up and the other goes down? right? So we're looking at how those two things are connected. And we use something called a scatter plot to show that relationship. Okay, but before I show you what some scatter plots look like, I want to be very, very clear about something. When two things correlate, you cannot say that one causes the other. A correlation is not the same thing as a causation. Ever. Never, 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 never. Okay? And there are some weird correlations in the world that are clearly not causations, and we'll talk more about that tomorrow. Okay? But correlation is not the same thing. Just because two things rise together or fall together does not mean that one causes the other. It is not a cause and effect relationship. Okay? All right, so you're going to need to copy these down because these are going to be, you're going to be tested on this. This is a really important way to read data, and we're going to be looking at a lot of these through the year. Okay, so these are some examples of correlations. So you might see something like this that looks like a pretty strong diagonal, and if it's going up, that's a positive correlation. It means that they're both rising at the same time, right? So as we come further out on the x-axis, we also come further up on the y-axis. You might also see a low positive correlation. So this is where there's like kind of a relationship, but if you were to draw the line best fit here, you would miss most of the points. Here, you would get quite a bit of them on that line. Okay. Then we have one where there's just no correlation. There's no relationship. We can't see them together. All right. And then we're going to have a negative low correlation. So again, this is going from up to down, right? This is going down. And if we drew our line best fit, we would get some of the points, but not a whole lot. We'd have quite a few outliers. And then by the same token, we have a high negative correlation. So it's just like the high positive correlation, it's just going the other way. It means that as one thing goes up, the other thing goes down. And you can see that here. So as we go up, get higher on the x-axis, we get lower on the y-axis, right? And again, if we drew our line best fit here, then we would probably hit most of the points, or at least they would be very close to our line. Okay, so now let's talk about a survey. You've actually probably done a whole bunch of these. I know I've given a whole bunch of these in school. So this allows us to look at a ton of different people. We can do really big surveys, like 1 million people surveys. And the people self-report their answers. So no one's watching them. They're not in a lab, right? They're the ones telling you what's going on. So there are issues with this because of that. So the first thing is that participants might lie. So for example, in 2016, when there were polls taken about if you were voting for Biden or Trump, or for Clinton or Trump, people lied. And because they didn't want to admit that they were going to vote for Trump, so they said Clinton, which is why we all thought she was going to win, right? And then we woke up the next morning and found that people had lied on their surveys and Trump was their president, right? So sometimes these can have pretty big stakes. Sometimes people might not understand the question. So I know I've tried to be very clear on some survey questions and still got responses that just did not seem to make sense because people didn't understand. Another problem with this is that the way we actually phrase the question might affect the answer. So let's say I showed you a video of two cars getting in an accident. Okay, they run into each other at a stoplight. One of them rear ends the other one. If I asked you the question, what speed were the cars going when they hit each other, versus the question, what speed were the cars going when they smashed each other, you would tell me a lower speed for the first one than you would for a higher. And there have actually been studies done on this. So just by the way we ask the question, we can influence the answer. No bueno, right? That's bad. Okay. Another type of experiment is naturalistic observation. So, this is the type of stuff that somebody like Jane Goodall did, right? She worked with apes. So, this is when we're watching the subject in their natural environment. We go to the jungle or the woods or the desert, or we're looking at people in the city, whatever it is. And, excuse me, all we're doing is describing the behavior. Naturalistic observation does not explain behavior. It does not try to find causes for behavior. It simply describes what's happening. And this limits it, right? Because we can gather all this data about what's going on, but it's hard for us to figure out why. So we also have case studies, and those are the opposite of surveys. With surveys, we can get data from a lot of people. From a case study, we're really going in depth with one person or one group. So, for instance, there's a guy named Kim Peek. He's the real life Rain Man. He's so smart, and there have been a million case studies done on him. Or maybe we're doing a case study on somebody with depression, right? We're going really, really, really deep. So these can be really useful because they can give us things that we can apply to other people, but that's not all. If we find something in a case study and we think, oh, maybe it's that way for everyone or for a lot of people, then we need to perform other types of research. We need to perform actual experiments so that we can confirm that theory, right? If we're just generalizing from one person out to a whole group of people, that's dangerous. And you can see that happen when we look at stereotypes, right? So if we take the stereotype that, like, I don't know, white people are super bougie and they really love sports like tennis, right? If you find one white person who really likes tennis and you're generalizing, you might think that everyone does. Spoiler alert, I hate tennis. I think it's horrible. But, like, you see what I mean? It's dangerous. That's going to lead you down the wrong path. Okay. And that's part of where we get stereotypes from, but more on that later. Okay, so now what you're going to do when you go into your activity or your assignment is you're going to be trying to identify, excuse me, I'm so sorry, guys. You're going to be trying to identify what type of research you think a study is. Okay, so pay very, very close attention to the wording of what it tells you, because that's going to be your clue. Okay, so I'm going to stop here. Again, if you have questions, you can always let me know.